Hello guys, welcome to my channel Chemical View. In previous lecture I have been taught about the elimination reaction. We have talked about three types of elimination reaction, that is E1CB, E1 mechanism and E2 mechanism. For E1CB mechanism we have done. Now we are discuss about the E1 and E2 elimination reactions with examples. We know that for E1 mechanism the living group capacity should be very high. There are examples of even elimination reaction for a living group, that is OTS, OBS, OMS, etc. That is the capacity of living group should be high, which will easily live. That is the even elimination reaction. Now let's discuss about the first example, that is secondary alcohol with HBr and water. What happens in this reaction? Here the lone pair of oxygen takes up the hydrogen and forming the water, and we know that water is very good living group, so it lives. Then what happened? Then the carbocation generate on this carbon atom. Now we have to balance this carbocation. For that there are two possibilities for the balancing of this carbocation, that is from this carbon atom and also from this carbon. So this is nothing but the CH3. Okay, so now first of all we are taking this hydrogen atom. You know that the carbon has carbon is carbon has four valencies. So the 1 2 3 4. So there is nothing means there is a hydrogen present, so this hydrogen will shift here. So here are two possibilities. So let's take one possibility, that when there is hydrogen, when the bond shift towards the carbocation, then the products form is like this, that is the more substituted product. And now if you are taking this CH3 as a when the bond of hydrogen is shifted towards the carbocation, so we got this minor product, and this is more substituted product. We know that the more substituted alkene is more stable, thermodynamically stable. That is and this is accordance with the Sedgwick rule. Sedgwick rule says the more substituted product is more favorable. So now let us consider another examples. Second example of even elimination reaction. Here is the tosylate group, which is very good living group. That is OTS is a very good living group. So that here what happened? Now here is the hydroxy group. Group, the lone pair of oxygen atom takes up these protons, and elimination of water first of all takes place. So and also the tosylate group is the source of H positive, that is the proton donor also. Now what happened after the elimination of water? What we get? Positive sign here. And now this is nothing but the CH3 group, that is we can write there CH2 CH3. This is also CH3. Now the bond will shift like this, and we got the product like this is the 6-membered ring. This is 6-membered ring, and this there is no stereochemical change here. After the shifting of bonds, what we get? Alkene. Less substituted alkene will form. Okay. Now the third example is this is the bridge head position of the carbocation will form in these examples. Let's see. Here is the cyclic ring. What happened here? The lone pair of oxygen takes up the hydrogen, and we got the elimination of water, and now this water, the OH, the oxygen is becomes positive. Why? Because 1 2 3 this becomes trivalent, and we know that oxygen is a divalent atom. So that after the elimination of water, what we get here? The carbocation will form, and we cannot allow this carbocation at the bridge head position, because this is the bridge head position which is not suitable for the reactions, so that the reaction does not occur. The carbocation will not form according to the Brett's rule. What Brett's rule says? The carbocation at bridge head position is not allowed. Now in another examples, guys, we should know about stereochemistry, because which is very much important in the while we are doing the reactions. Okay, so what happened is the two phenyl group are given antiperiplanar. So we can write like this in this manner. Okay, in this manner, this is first carbon and this is second one. Okay, it's antiperiplanar condition. That is but what happens if we want to attack HCl? The hydrogen and the living group should be in antiperiplanar, that should be in plane. should be in plane. Okay, so what we have done, the rotation, we have taken the 120-degree rotation, and so that the hydrogen which was in plane, it comes to be, which was comes to be in below the plane like this. Clockwise we are rotating this 120 clockwise rotation, so the hydrogen comes in below, and this methyl goes to above, and finally we got the hydrogen in plane. After this, in this carbon, this is carbon C1 and this is carbon C2, second carbon. So this is also, the living group is Br, and that should be in the plane, so that we have taken the 120-degree rotation. So here we got the hydrogen was in plane, pH group which was in plane, that comes to be in below position, hydrogen above, and the living room bromine in the in plane. Now it is possible this, we have given a base which is abstracting the proton, and the bond will shift like this, and we got the axial anti-periplanar attack. And after that we got this product, after that we got this more substituted product. Okay, we can say the side step product. We got more substituted alkene is also, more substituted alkene is more stable. This rotation can be done after a 60-degree rotation also. If you are more, if you are doing in this manner also, then you also get the result correctly. Thank you so much. Let us consider the another example of E2 elimination reaction. Here we know that E2 elimination, in E2 elimination reaction, the attack is anti-periplanar attack of the nucleophile when attack this hydrogen. This nucleophile when attack this hydrogen, the elimination takes place anti-periplanar. Let's consider this is Z means the living group. Okay, Lg is equals to Z. This is a living group. Okay, now in this compound, what happened, the base is given and 250 times slower. What happened, let us draw the 6-member cyclic ring to understand what actually the attack is taking place. So that here we are counting from this, because the bulky group always put at equatorial position, so that we are, and this is equatorial below, so this is axial hydrogen and equatorial below here. And after at the second position there, the Cl group is attached, which is above. So we are equatorial above, we have putting the Cl group, and axially the hydrogen. And after the fourth position there is the CH3, that is methane. But actually what happens, the according to the elimination reactions, the attack should be axially position. But what happened here, the scene will take place, so it will not allow the elimination reaction. So what we can say, we can what we do, that we should flip the ring or inversion. So after inversion, what we get, firstly the first position will be the below, at the below side, and this is the bulky group. And now the at second position there is a, we are putting this Cl axial. Okay, this is the living group which is putting at axial. And now third carbon, there is a hydrogen. Okay, and at fourth methyl will be given, that is above, axial above. Now what happened, we have given the base, that is Na plus and OET minus, that is sodium ethoxide. So ethoxide group, ethoxide is the base which is abstracting this proton, and the bond will shift like this, and the elimination of Cl group will remove. So what we get here, the bond is comes between 2 and 3 position. Okay, this is bond will come at this position. Okay, and other groups are remaining as it is. So we can write here in a simple way, one, two, three, 4. Here is the CH3, and the bond is between 2 and 3 position, 1, 2, 3. Here we got the double bond. Now let us second example. This is example so important, because by mistakenly we write the products, but actually the reaction does not occur, because there is no fate of this reaction. Why? Because here we have taken this 6-member cyclic ring, in which the the axial is the chlorine, and axial above chlorine is the methyl group. Here is the hydrogen also. Now we have taken the base ethoxide OR minus. When this base abstract this proton, then there will be elimination reactions. It's okay. But after if you are taking this base, this can also abstract this proton. This can abstract the proton, and the Cl will remove. But so the condition, what happens actually here, the repulsion of 2 hydrogen in the ring will be occur. So it causes some steric hindrance, so that we have to avoid this, so that and the attack should be anti-periplanar. Here we got the anti-periplanar, but here is also got the anti-periplanar attack, so it's not possible. So maximum hindrance in the ring will occur, and that's why the reaction will not occur. Now we are getting this product, but the reaction has no fate.